Welcome to this video on vector subspace for Gate DA, linear algebra, presented by Professor Manish. A subset W of a vector space V is a subspace if it satisfies three conditions. The first condition is that W must contain the zero vector. The zero vector must belong to the subset. The second condition is that W must be closed under addition. If U and W are in W, then their sum, U plus W, must also be in W. Adding two vectors from the subset keeps you inside the subset. The third condition is that W must be closed under scalar multiplication. If C is a scalar and W is in W, then C times W must also be in W. Multiplying any vector by a scalar remains inside the subset. There is a shortcut, the subspace test. Instead of checking all vector space axioms, a subset W is a subspace if, for all U and V in W and scalars C and D, the linear combination Cu plus dV is in W. This combines addition and scalar multiplication. Let's look at an example, a line through the origin. Consider W as the set of vectors x, 0 in R squared. This represents the x-axis. We check the conditions for the x-axis example. It contains the zero vector 0, 0. It's closed under addition. x1, 0 plus x2, 0 equals x1 plus x2, 0, which is still in W. It's closed under scalar multiplication. C times x, 0, equals cx, 0, which is still in W. Hence, it is a subspace. Another example is a plane in R cubed. Consider W as the set of vectors x, y, 0. This is the xy plane. It contains the zero vector and is closed under addition and scalar multiplication. Therefore, it is a subspace. This example confirms the xy plane, defined as W equals the set of vectors x, y, 0 in R cubed, is a subspace because it contains the zero vector and is closed under both addition and scalar multiplication. Now, an example of something that is not a subspace. Consider W where x plus y equals 1. If we check the zero vector, 0 plus 0 equals 0, which does not equal 1. Since the zero vector is not included, W is not a subspace. Let's look at the geometric interpretation in R squared. Subspaces are the origin, any line through the origin, and the whole plane. In R cubed, subspaces are the origin, any line through the origin, any plane through the origin, and the entire space. Importantly, a subspace must pass through the origin. To quickly summarize, a subset is a subspace if it contains the zero vector, is closed under addition, and is closed under scalar multiplication. Thank you for watching this video.